In this video note, we're going to introduce the Zool project. We shall demonstrate what is a fairly simple text-based adventure game and then discuss the desire to add more functionality to it. We shall then walk through the opening steps involved in refactoring the Zool Bad project. We shall also introduce the String Builder class. From the demonstration it can be seen that we have the basis for a promising game and we'd like to add some more features to it. However, the poor quality of the code in the Zool Bad project will make it a lot harder to introduce new features than if we'd taken a bit more care over writing it in the first place. Therefore, before we start to develop the program further, we need to undertake a process called refactoring. Refactoring involves changing the structure of code in order to improve its quality. The idea is that, by refactoring, we shall end up with a version of the program that's a lot easier to add new features to. Furthermore, if we adhere to the principles of good quality in the features we then add, we'll end up with a program that will be a lot easier both to maintain and to develop further in the future. An important point to appreciate when considering the work we're going to undertake, therefore, is that our immediate intention is not to add any new functionality to it at this stage. However, that remains our long-term aim. The first example of poor quality that we identify is the presence of code duplication. We can see code in the print welcome method that we later find duplicated in the go room method. The problem with duplicate code is that it is hard to avoid inconsistency creeping in between the multiple copies when we make changes. While it might be argued that this problem is easily solved by cut and paste following a change, i.e. pasting the new version in all the places it's required, this assumes that we actually know that there are multiple copies of a piece of code being changed and that we know where they all are. A better approach to duplication is to place the duplicate code in one place in a separate method and then invoke that method from all the locations where the code formerly was. If there are minor variations in the code in different places, it will often be possible to take account of those by giving the method some parameters. Let's illustrate this approach by defining a printLocationInfo method for the duplicate code in printWelcome and goRoom. Firstly, we write the basic method wrapper. Note that we define this method as private because we're not intending this method to be callable from outside the class. Then we add a call to the new method at the position of the first copy, then cut from there to the body of the method. We can make any necessary adjustments to indentation. Then we find the location of the second copy, and replace it entirely with a call to the new method. We can compile at any desired point in the process and fix any errors we've introduced. Rather than continuing with the next stage of refactoring as it's covered in the book, we're going to make an additional change to this method that does actually anticipate part of that next stage, but is not covered in this way in the chapter. Notice that what this method does with the available exits from the current room is to print a list of them. Of course, that's because that's exactly what was being done in the original version, and what is obviously required here. However, it turns out that a much more generally useful approach for methods like this is to have them prepare and return a string consisting of what they would otherwise have printed. Those parts of the program that call such methods can then print the string out if that's what's required. You will see this idea used a lot later in the book when we discuss inheritance and the toString method that classes often define as a way of representing object state. We'll do this now because building a string out of other strings, as we have here, is a common task. So far we've only seen how to do that using string concatenation, but you will recall that strings are immutable objects. So the concatenation process actually involves a succession of object creations, as new strings are built, only to be discarded shortly after as further pieces are added. To overcome some of the limitations imposed by the immutability of strings, there are a couple of classes in the java.lang package that are designed to make the string building process more efficient. One is called string buffer and the other is called string builder. We shall use string builder here. You can find details of both in the API documentation. Firstly, we change the header of print location info so that this doesn't get forgotten. We shall need a string builder as a local variable. The string builder is not itself a string, so at the end of the method we shall have to ask it to return a string version of itself. The most commonly used method of string builder is append, which takes a string to be added on to what's already been built. So all of our print statements will now become calls to append. We have to take a little bit of care over replacing the call to println because that silently adds a new line character to the string being printed. So we'll make a change in two stages. First we append the main string. Then we add a new line, but we have two choices for this. A new line is represented by \n. We can either append a string containing a single new line character, or we can append a character literal. Character literals are written between single quotes rather than double quotes. You can read more about characters in one of the appendices. We won't actually append a trailing new line to the string being returned. If those parts of the program that are calling this method wish to print it with a new line on the end, they can do so themselves. So now we're going to replace those calls to print location info to calls to get location info, where the string being returned is then passed to the println method. To summarize, in this video note we've discussed the fact that it's sometimes necessary to refactor code in order to improve its quality. This process is often required before we add new features to a program. We saw one particular example of poor quality code in the form of code duplication. We eliminated the duplication by creating a new method to store the duplicate code. We also introduced the string builder class as an alternative to string concatenation when creating new strings out of multiple pieces. Finally, we iterate that none of the changes we've made to the code have changed what the game currently does, but they've been the first step towards improving its overall quality.